I'm going to be working through a few examples from the Discovering Transformations worksheet in this video. And I have this worksheet on my Blackboard, but I will also have a hard copy for you in class if you need it. All right, let's get started. Use the given graph of f of x and g of x to discover the following transformations. So on the left we have f of x, and it's like this little m, and then g of x, we have this curve. So first of all, let's go ahead and just look at the domain and range. For this video and worksheet, I'm going to be using interval notation, but know that you could use set builder notation as well. Okay, so for the domain, I see that I have a continuous graph and there are no breaks in my graph. So my domain, my smallest value for x is -1. And then my largest is 1, 2, 3. And these are both closed points, so I'm going to use the square brackets. And then for my range, my smallest y value is -1 again. And then my largest y value is 1, 2, 3. And again, these are closed points, so I have the square brackets. Looking at g of x, it's also a continuous graph. My smallest x value is this one over here, so it's 1, 2, 3, 4, 5, 6, -6. And my largest is 1, 2, 3, 4, 5, 6. Closed points, so I need square brackets. And then for my y values, my smallest y value, I have 3 points that share that y value, and it's at 2. And my largest y value is 1, 2, 3, 4, 5. Again, with square brackets, since these are closed points. Okay, now before we move on, there's a couple of things that we should discuss. First of all, when we're doing transformations, we're talking about moving the graph left, right, up, down, stretching it either vertically or horizontally. So to figure out what you're supposed to do and the order that you're supposed to, let's see. So if you have F, or it doesn't matter if it's G or H or whatever letter, and then you have whatever's in parentheses. Anything that is in the parentheses, that is going to involve horizontal changes or transformations. And because it's inside here and it has to do with how we find functions, and you'll see this a little bit better when we use an actual function versus these little made-up little graphs, you actually do the opposite of what it seems like it's telling you to do. I'll show you what I mean by that in just a second. But if you have anything that's in front or outside the parentheses, then that is going to be a vertical change or transformation, and you're actually going to do exactly what it says. You're going to do the same thing as what it says you're doing. So the main thing is that inside the parentheses is with x and its opposite, outside is for the y, and you're going to do what it says. You do the same thing as what it says. Okay, one other thing that you need to know is the order that you have to follow the transformations. First of all, you have to do left and right first. So that means you're looking at what is being added or subtracted inside the parentheses. Second, you're going to do the horizontal stretch or compression. So that will be whatever's being multiplied inside the parentheses. So we deal with what's inside the parentheses first. We deal with the x values first. Third, we'll do the vertical. We do the opposite of what we did in the first one. So we'll do the multiplying of the y values. That's the thing sitting in the front here that we're multiplying by. We'll do the vertical stretch or compression next. And then last, we'll go up or down. So just kind of roughly showing you what left and right, you would look at what's usually, this is usually, you may have to rearrange it to get this. So you're looking at what's sitting here first, moving left and right. Whatever's in front of the x, you're stretching it horizontally, you're stretching or compressing it. Then you look at if you're multiplying your y values, which means vertical stretch or compression. And then last, you'll move up and down. So let's look at a few examples together. So on number 1, let me leave that so we can still see the original one. Okay, so you know on the graph, or you may notice, this isn't going to be on yours, but just for the sake of this video, I went ahead and put in this light gray color the original graph, because we're going to look at what we have over here. Notice that the original function was called f of x, and you can see now that we have a plus 2. It's inside the parentheses with the x, so that means this is a horizontal transformation. Now since it's being added, that means we're moving it left or right. Well, you may be inclined to take each point, its x values, and add 2. But actually, we're going to do the opposite, because with x, we always do the opposite. So this is a horizontal transformation. Okay, but the transformation that we're going to be doing is moving everything to the left 2. So if I take each point here and move it just to the left 2, 1, 2, 1, 2, and it may be easier for you to start out by drawing the original graph, like I have the gray graph on here. Okay, so in green, that's my new graph. So for the domain, of course, if my graph moved to the left 2, my domain got moved to the left 2 as well. So my smallest x value is now -3. Whoops, -3. 1, 2, 3. And my largest x value is 1. So my domain is -3, 1, and it's still square brackets because I have closed points. But looking at the range, I didn't move anything up and down, so my range will stay the same as what it was before, -1, 3. So comparing what it originally was to what it is now, everything has just moved to the left 2. Okay, let's go down here to number 3. Let's look at one that has g of x. This time, the change that's happening, if my original graph was g of x, I'm adding something outside of the parentheses, so that means it's going to be a vertical transformation. And anything that has to do with the y, you're going to do exactly what it says to the y values. So it said +2, that means you're going to take each of the y values for each point and add 2 to the y values. So we're going to be moving up 2. So if I take each of my points and move it up 2, 1, 2, 1, 2. Then I just connect them in the same way. That's my new graph. Okay, so because I didn't move anything left and right, my domain has not changed. My x values were not affected for each of my points. So my original domain, looking back up here, was at -6, 6. And looking at our graph now, our domain is still the smallest is at -6 and the largest x value is at +6. So the domain does not change, -6, 6. But the range, because I moved up 2, all of my y values should be up by 2. So originally, my range was 2, 5. Well, now because I've moved it up 2, my smallest y value is 4. And then my largest one is 7. So my range increased on each of the values by 2. Okay, so let's keep going to number 5. Okay, so on number 5, my original function, again, was f of x. So comparing that one to this one, I can see that I have this 2 sitting here. And it's inside the parentheses with the x, so that means it's going to be a horizontal transformation. But we're not really multiplying by 2, we're actually multiplying by 1/2, which is the same thing as dividing by 2. So because of that, let me just go ahead and start using the graph, and we'll talk about the transformation here in a second. So if this x value was at -1, we're multiplying all of the x values times 1/2 instead of 2 is what it looks like. You do the opposite. So -1 times 1/2 is -1/2. So this x value of 0, 0 times 1/2, it won't go anywhere. This x value of 1 times 1/2 is 1/2. This x value of 2, so 2 times 1/2 is 1. And then this x value of 3, 3 times 1/2 is 3/2, which is 1.5. So our graph got squished, if you can tell. My points are really close together. But because we were changing the x values, this is a horizontal. We squished it, so it's a compression. And then there's this little phrase we have to add, by a factor of, or we could just write by, but by a factor of, it's what we multiplied by. So by 1/2. Horizontal compression by 1/2. So our domain, our smallest x value here is -1/2, and then our largest is 3/2, or 1.5. And if we compare that to the original, these are 1/2 of what they used to be. But the range, we did not change any of the values for the range. Those points still have the same y values that they used to. So the range was -1,3 before, and it's going to stay -1,3 now. Number 7. Okay, on this graph, the 2 is not with the x. So because it's outside of the parentheses, that means this is going to be a vertical change or transformation. But remember, anytime we're dealing with the y values, we're going to do exactly what it says. So if it says times 2 here, then we're going to take the y values and multiply them by 2. So leaving the x values alone, I just need to look at their y values. I'm going to multiply each one by 2. So this had a y value of -1. Now it's at -2. This y value is at 2. Well, 2 times 2 is 4. This y value is 1 times 2 is 2. This y value is 3 times 2 is 4, 5, 6. This y value is 0, and 0 times 2 is still 0. So my new graph looks like this. So because we changed the y values, this is a vertical transformation, and we stretched it. So our two options are stretch or compress. Well, it got stretched because it got taller. Stretch by a factor of, we multiplied by 2. So our domain before, on the original one for f of x, it was -1,3. Well, it's still the same now because we didn't change anything with the x value. So it's still -1, 3. But the range, we multiplied all of the y values by 2. So the original range was -1,3. So if we multiply each of those by 2, it should match what we have here. So our smallest y value is -2, and our largest is 6, whereas it used to be 3. Okay? So there's number 7. Let's do one more together. Let's look at number 9. On this graph, we have a minus sign, and it's sitting inside the parentheses with the x. That means that this is going to be a horizontal change or transformation. And just like we did back on number 5, we just have to multiply by the reciprocal of whatever it originally said. So if it says 2, we multiply by 1/2. If it had said 3, we multiply by 1/3. Or if this had said 1/2, instead we would multiply by 2. Well, multiplying right here, that's a -1. Well, the reciprocal of -1 is still -1. So we're going to take all of the x values and multiply them by -1. So taking each of these x values, this x value is at -1 times -1 is now +1. This x value is 0, but 0 times anything is still 0. This original point had an x value of 1. 1 times -1, -1. And this x value was at 2. Now it's at -2. And this x value is at 3. Now it's at -3. So if you compare the original graph to the one that I have in red now, you can see that it's a reflection over the y-axis. So that's our transformation. We're going to reflect over the y-axis. So this tends to be one that everyone gets a little bit confused with, because we're multiplying the x values by something. It's easy to think, okay, reflect over the x-axis. But be careful, because multiplying the x values by -1 actually reflects over the y-axis. So make sure you keep that straight in your mind. Okay, so for the domain, our smallest x value is now -3, and our largest x value is 1. But the range, of course, does not change because we didn't multiply the y values by anything. So it's still at 1, comma 3. Negative 1. Whoops. Negative 1, comma 3. Okay, and that is it. I hope that this was clear, and if you have any questions, let me know in class, and I hope you're having a great day. Bye.